Hey everyone, my name is Harry Crocker, and I'm excited to share with you my project where I improve an everyday product. The everyday product that I chose to improve is a space mouse. Now, this is different from a normal computer mouse, and it enables you to quickly manipulate 3D models and navigate much more intuitively with the computer. It has a pan, zoom, and rotate functionality as shown in the top right. And this isn't just limited to engineers, architects, and graphic designers, but can be used by all sorts of people to improve their experience using a computer. Now, some of the limitations with this is it lacks a portability because it has a wire, which is messy, and this also means you always need to be plugged in. There's also no ergonomic grip, so your fingers can slip. Here's my solution to these problems. I've added an ergonomic textured grip to improve the user interface with the product, and I've also added wireless charging capability. This design is much smaller, and the minimalistic approach aids the portability as there are no messy wires. This product takes advantage of the modern phone reverse charging capability. So in most modern phones that are able to wirelessly charge, there is an inductor inside them. Now, usually this is used to charge the phone, but this can be reversed so that the inductor in the phone can transfer charge to the wireless space mouse, which also has an inductor inside of it. Now, a lot of iPhone accessories use MagSafe technology, which is a magnet built into the phone, and this is how the Space Mouse will interface with the phone to stay connected and not fall off of the iPhone. And the idea here is that everyone always has their phone with them, so they will be able to quickly use this Space Mouse and not need to worry about plugging it in somewhere. The materials needed for this product are a TPU rubber for the grip, which is kind of squishy, and then an ABS plastic for the base, which would have a matte surface finish, and then also ABS plastic for the top, which would have a glossy surface finish, just to improve the aesthetics, and then an aluminum ring made out of 6061 to give it a more premium feel. Also, inside there are complex sensors and also springs, which is how the joystick is able to measure force displacement. Here are the manufacturing processes to create the components I discussed on the previous slide. The TPU rubber will be overmolded onto a central piece, and then the top and bottom components will be injection molded. Then they will be finished to an SPI standard, either matte or glossy. And this is the Society of Plastics Industry, which specifies the requirements and standardizes the finishing processes for injection molded parts. Finally, the aluminum ring will be made on a CNC lathe, as this is a circular or a cylindrical part, which is much more efficient than using a CNC mill. Injection molding works by first taking a bunch of plastic pellets and putting them into that funnel. Then the pellets drop down and are heated up, and a worm screw pushes the plastic or the molten plastic forward into the mold. Then it is pulled back as you can see in the GIF, and the mold opens up, and there are ejector pins which punch out the part, and it falls into a bucket. This is a very common process for any mass-produced plastic parts, as it is very quick, very efficient, and highly repeatable. On the right are the standard finishing processes. As I mentioned earlier, I will be using A3 and C2. Overmolding is a very common process used to make grips on all sorts of components. This shown here in the picture is the grip on a tool. This will be very applicable for the 3D texture with a nice ergonomic feel that I'm looking for on this Space Mouse. On the right is the CNC lathe that would be used to make the aluminum ring. The part is first put into the chuck, tightened, and then this is spun up, and a cutter comes in and trims away material, and then reams out the inside, and then you would be able to cut off the part. Once this machine is programmed, it is easy to mass produce these components. For the springs manufactured to go on the inside of the Space Mouse, so it's able to translate motion into a voltage that the Space Mouse is able to interpret to then move the mouse on your screen, the spring manufacturing process shown in the picture would need to be used. Here, a metal wire is extruded from that central portion, and then these different tools that are radially positioned around then come in to angle the wire coming out to be able to create that helical shape. Then finally, there's another tool which comes in to cut the spring off where it would fall into a bucket so that you're able to mass produce these. On the right is a wire drawing machine which would be needed to create the copper wire used in the inductor in the Space Mouse. This is done by heating up the copper and then pulling it through a shape to get a perfectly cylindrical wire. And you can see on those coils, they just spin up and slowly pull out the wire, and is another highly effective method of mass producing these components. Here is a final render of the product which shows it in action, being powered by the wireless charging from an iPhone. Some of the advantages of this product is that it draws a low amount of power and will have an unnoticeable effect on the phone battery life. It also enables an intuitive interface between humans and computers. Its ergonomic textured grip improves the user experience, and it is still small and portable, so you are able to take it wherever you go. Some of the disadvantages of this product is that it requires you to have your phone with you. However, this is a fairly common thing that most customers will likely not have an issue with. It is only compatible with modern phones that are able to wirelessly charge, and the cost of a Space Mouse is higher than a normal mouse due to the advanced sensors and small intricate parts on the inside. Here are the resources that I use to do research on different manufacturing processes and create this project. Thank you for listening to my presentation, and I hope you enjoyed learning about this new innovative Space Mouse.